camera is not doing. Okay, what about now? It's good? Can you hear me? Guys,
Yes, Professor.
hello? Can you hear me?
Yeah, we can hear you, Professor.
Hello? Zoom, can you hear me? Did they
Yes, sir, we
answer?
can hear.
Can you hear me?
Yeah, it's good.
Yes, sir.
What
Yes,
about now?
Professor.
Can you hear me? Say yes, okay. Hopefully I'm not gonna touch it again. So let's see. So from the first one, as we mentioned, what is the suffix? What's the prefix? Is the 12. So can you tell me from, if you know the suffix, prefix, and it's 8 bits. Can you tell me what is the mask? What is the mask? So that's me. Remember how we calculate the mask? Do it here. So if in a class A, if I tell you I have a class A, how much the n in the class A? 8, correct? How you will find the mask for that? We did that last week. So the first 8, you make them all of them ones, and the remaining zeros. So it's going to be zeros here. So what is this one? When you have everything 8, it's 255.0.0.0, correct? So now it's really simple. If you know how many bits represent the prefix, so this first 8-bit or 16-bit or 24-bit is going to be ones. The remaining will be 0. So that's why we found the mask here. Because the first 8 bits it's 1 1 1 1 1, and the remaining is zeros until the total, correct? Then you represent it by the binary. Oh, I'm sorry, by decimal. All right. So what we found here, can you tell me what we learned so far? From this one, we learned n equal 8. That means the prefix is 8, and the suffix is 24. Okay, now the question for you, can you tell me how many IP addresses I have here in this block? The IP range. 2 to the power? Correct. Because remember, since we have 8, so 32 minus 8 equal 24. So how many IP addresses we have? 2 to the power 24. That's how many IP addresses they have in this range. Can you tell me what is the first IP address? The first IP address. That's really easy. So that you will leave the first 8 because always it has to stay the same. Then the remaining will be usually start with zeros. So what is the first number or the IP address? It will be 12. That's the first 8. Then the remaining 0. So it's going to be 0 0 0. That's the first IP address in this range. Now, how we will find the IP address in the last? What is the last IP address in this range? I will show you later. But so far, we learned something here. So let's do example B. Okay, what is this address? Now, if I tell you this one, it's a class full. Can you tell me, is this class A, B, C? Class B. Class B, correct? But since we are talking about classless, so we don't have to worry about class A and B and C. But from here, what you know from the 16 here? What you can tell me from the 16? First 16 is the prefix, correct? And the remaining 16 is the suffix. Now, if I tell you how many IP addresses I have in this range, can you tell me how many IP addresses here? 2 to the power 16. Good job. That's the total IP addresses. Can you tell me what is the mask here? Remember the mask, what you do? The prefix, you leave it ones, and the suffix, you make it zeros. So in this case, what I will do, the first 16 is ones. Correct? Then you will have 0, 8, and then another 8. So what is the number here? 255.255.0.0. So I found the mask here. Perfect. Now let's go to the other one. What this one? What is the from the 27? Can you tell me what's the 27 represent? And how much for suffix? 27 to 32? 5? Correct. So is that, so how many IP addresses they have? How many IP addresses they have? 2 to the power 5. That's how many IP addresses I have. What is the mask? What is the mask? Can you tell me now what's the mask? That's going to be, we have to do some work here. That's not an easy one. So what is the mask here? The first 21 bit is ones. So 1, 2, 3, 4. So first 8, you have 8, then you will have 8. So that's 255. This 255. Now that's 16. Then until 27, how many you have? Until the 24, another 8. So 255, correct? So then you will have another 3. Then the remaining zeros. So what is this number? If you count, if you do the math, you know how to calculate this one, how you transfer that to decimal? Can you tell me what's the number? I know the number here, but can you tell me how you find that? Again, remember last week we say you have to write this number 1, 2, 4, 8, 16, 32, 64, 128, 256, correct? Oh, 8. So okay, here. So that's 8-bit. So here, that's 0, 0, 0, 0, then 0, 1, 1, 1. So what you have to do, you will do 128 plus 64 plus 32. That's equal 224. So that's how you find this number, 224. All right. So what is the mask here? 255, 255, 255, 224. Okay. So now again, I have an IP address and I have the notation, the annotation. From this two, I can find how many IP addresses I have. I can find that mask. What else I can find? The first IP address. I can find the last IP address. So we'll show you that. Okay. So next page. All right. So the number of addresses in this block, I mentioned that multiple times, is, what is the N? That's a notation. That's I have to give it to you. Without the N, you will not be able to know what is the prefix, what is the suffix, correct? So I have to give you that. So if I ask you what is the range, how many IP addresses they have, simply, it's 2 to the power 32, but here's a mistake here. Sorry, there's that. Yeah. What is the mistake? Can you tell me what is the mistake here? So it's not minus N here. It should be 32 minus N. Correct? So let's say your N equal 8. What is the range? It's 2 to the power 32 minus 8. It's equal to 2 to the power 24. All right. So if N equal 3, can you tell me what is the range? 2 to the power 32 minus 3 equal 2 to the power 29. Simple. So I can't tell you, I can't find what is the range. What's the second piece? The first address is going to give you the network address. Remember, we're showing a real example. So first address, what is the first address? How do you find the first address? Any IP address, you end it with what? The mask. Do you know how to find the mask? How you find the mask? We did that like the last slide. How we find the mask? From the N, you know, the n, all the n, like, you know, if you have n equal 8, that's mean the first 8 will make them ones, and the remaining will make them zeros. Then you will find the mask number. Perfect. So now, since you have the mask number and you have an IP address, you will be able to find the first IP address. How you will find the last IP address in the range? It's really simple. It's going to be IP address. You OR it with the mask, but not the mask. We will show you now. Clear? So that's in the exam. I will give you an IP address. I will give you the notation. The first question I will ask you how many IP addresses, and we know from here. Okay, what is the first address? It's from here. What is the last IP address? It's from here. Okay, so let's do some example. Now, first, this one, this address. Can you tell me what is the mask address? So that's mean the first 27 will make them ones, and the remaining 5 zeros. So same thing. It's going to be 1, 1, 1, 1. 27 of them. Then the remaining 5. It's going to be 0, 0, 0, 0, 0. If you translate that, it's going to be 255. Dot 255. Dot 255. Dot 240. Okay. So that's the first step. You have to find that. Now, how many IP addresses I have in this block? Can you tell me how many IP addresses? What's the, remember the equation? 2 to the power 32 minus n. How much the n? 27. So the answer will be 2 to the power 5 equal 32. So I have only 32 in this block. Now if I have a question for you, what is the first IP address? How will find out? Any IP address, you end it with the mask. So this is the address. That's the address. What's the address here? 167, 129, 170, 82. This one is 167. This one is 199. This one is 170. This one is 82, correct? Then you end it with what? You end it with 255, 255, 255, 240. So can you tell me what is this number? I'm sorry, this one. That's 255, correct? What about this one? 255. What about this one? 255. What about this one? That's 240. Simple AND. Can you tell me what's the AND? Can we do that together very quick? What's the AND operation? If both equal ones, the result will be 1. If any one of them equals 0, the result will be 0. So for example, I'm not going to do all of them. So 0 and 0, the result will be 0, correct? Now, if you do this one, 1 and 1, the result will be 1. Grab anyone, 0, 1 will be 0. So that's the result. If you do all of them, it's going to be like this. If you translate that to, I'm sorry, if you translate that to a dot notation, can you tell me what this one? What is the IP address here? What is this one? It's going to be 167 dot, okay, 199 dot 170 dot, what is this one? It's 64. So that's the first IP address. Simple. Now, if you want to find the last IP address, what you have to do? You OR it with what? Not MAC address. I'm sorry, mask address. So what is the mask, if you remember? What is the mask initially? It's 1, 1, 1, 1, 1, 1, 1, correct? But you invert it. You will make it 0, 0, 0, 0, 0, 0, 0, 0. That's why we have it 0, 0. So this one 0, 0, and this one 0, 0, 0. And this one is the nut of the 240. 240, if you do not, it's gonna be equal this number. This number is 16 plus 16 is 32. Anyway, so then you OR it. Now, can you tell me the OR operation? If you have 1 or 1, what's the result? 1. What about 1 or 0? 1. What about 0 or 0? 0. That's mean the result will be equal 0 if both of them 0. If any one of them equal 1, that's mean the answer will be 1. So we will find it. All right, so let's do numbers. This one may be easier, okay, because we see numbers. Okay, first of all, what is this IP address? How many IP addresses we have? Or before that, what is the mask here? The first 24 should be ones, and the last 8 should be zeros. So, and this one, the mask will be 255 dot 0, right? So that's the mask. From here, you'll find it here. How many IP addresses we have? 2 to the power 32 minus 24 equal to the power 8 equal 256. You know, we know that's class C. So we are talking about classless. Perfect. Now let's find the first IP address. How you find the first IP address? Any IP address, that's any IP address in the range, you add it with the mask, correct? If you remember last week, we mentioned that if you add any number with 255 or 0, that's the minimum and the maximum. You take what? You take the lowest. So, for example, so you don't have to, in the exam, you don't have to write zeros, ones, all the stuff. There is stuff you can find it right away. So now question for you. If you add 17 with 255, okay, when you add two numbers and one of them either 255 or 0, so then you can find the answer right away. You don't have to do math. So you take the minimum. So what is the minimum between 17 and 255? So you will take the 17. Okay, what about here? 255 with 63. I will take the minimum. Okay, what about this one? I will take the 110. Okay, then if I do 0 and 114, I will take the 0. So this one is so easy. Without any math, I can right away, I can find the first IP address. Now, if I want to find the last IP address, what we have to do? I will have the IP address. Then I will do not for the test. All right. So now in the OR, if you ORing with 255 or 0, you will take that. With the AND, we took the lowest number. With the OR, we'll take the highest. So if you do AND, hello? Test. Okay, so now if you do 17 or 0, what you will do? We'll take the highest. 36 with 0, so we'll take the 36. 110 with 0, I will take the 10, 110. 114 and 255, I will take the 255. So that is the last IP address. Easy. So from the IP address, and so I had two information in this question. I will have the IP address and I will have the AND notation. From there, I can find the range, I can find the first IP address, I can find the last IP address. Simple. That's for sure it's going to come in the exam. Let's just speed up. Okay. Another example. I'm not going to waste a lot of time here. So, what is the prefix 20? What does mean? How you can find the mask there? The first 20 equal ones, and the remaining is zeros. So 21s and 12 zeros. What is the mask? It's going to be this number. Correct? So how many IP addresses they have? 2 to the power 32 minus 20 equal 2 to the power 12 equal 4096 IP addresses. What is the first IP address? You will have the IP address, any IP address in the range, and what you have to do, and it with the mask. That's you end it with the mask. Few numbers you can do it without even doing any math. If you add 255 with another number, which one you want to take? The lowest. What is the lowest here? 110. 23 and 255. What is the lowest? I will take the 23. 14 and 0. What is the lowest? I will take 0. Now, where we have the issue? These two numbers, correct? Why we cannot do simple math here? Why we have to do a binary math? Can you tell me why? Because one of them is not 0, is not 255. So that's me now, I have to do the math. So how you do the math for this one? From last week again. So the 120, you have to write it in 0 ones. It's going to be long to do it, but you can do it. Let's say, 0, 0, 0, 1, 1, 1. 4 ones. It's not going to be 4 ones because it's 128. So it's going to be less than the last one. It's not going to be 1. So let's say, let's assume that's the number. Then you do the 12. 112. Let's say, the 12 is 0, 0, 1, 0, 0, 0, 1, 1, for example, and 0. So you do the AND, simple AND. Okay, so let's examine this 2. So it's going to be 0, 1, 1, 0, 0, 0, 0, 0. Then you add them. You add this 2, it's going to be 112. I'm not going to explain that. We did that last week. We did the 3 exercise on that. Correct? So if you missed that, if you have a question, go back to the last week presentation. You will know how to do the math there. All right? So simple. The other way to find the last one. How you will find the last one? You have the IP address. Then you will do NOT for the MAC address. Again, this one will be easy. Why? When you add 2 numbers with 0, one of them is 0, what I will take the highest. I will take the 110. Here I will take 32. Here I will take 255. Then you have to do this math by yourself. All right? So if you have a question, let me know. Clear? So the short summary here, the class list with 2 information I can find how many ID addresses in the range. I can find the mask, and I can find the first ID address, and I can find the last ID. Simple. So now the question for you: who would decide how many IP addresses I want to give this company? How many addresses I want to give this company? So there is an organization. It's called ICNA. ICNA is responsible to divide the IP address range, all right? But it's not dividing that to the end user. So the end user, you have to go through an internet provider. So ICNA is divide the blocks for the local IP internet service. So internet service, you have Verizon, you have Spectrum. So ICNA is divided to this organization. Then this organization divided to the end user. The end user could be a house, like my house, one person, could be a company. So we have companies. So what is the condition here? How do you do that? Again, remember the condition. The number of request addresses n has to be power of 2. I'm looking for 1,000 IP address. I cannot give somebody only 1,000. Why? Because 1,000 is not equal to 2 to power number. So what is the closest number for 1,000? Is 1,024. This one is 2 to the power 12. Perfect. So I need only 1,000, but they gave me 1,024. Okay, the 24 is going to be reserved. I can use it in the future, but I cannot just assign this company only 1,000. I cannot. It has to be 2 to the power a number. Clear? Since n equals 32 minus n, then the n, yes, That's if you wanna, it's the same thing. So if you decide to that's we explained that multiple times, so don't worry about that. Now the third condition here, if I'm assigning a company 1,000 IP address, it has to be continuous. So it has to be, for example, you start from 10.10.10.10. Okay, then the next IP address is going to be 10.10.10.11, then 12, then 13, then 14. I cannot give a company like 10.11, then give them 10.15, skip it like before. No, it has to be continuous IP addresses. All right. So that's the condition when they assign IP addresses to companies. All right, so let's do some math. Let's do some example. Okay, there is a company needs a block of 1,000 addresses. Can I do that? Can I assign 1,000? No. Why? It's not power of 2 to power number. So in this case, what we can do, we give them 1,024, 2 to the power of 10. So now the question for you, what is the prefix there? Can you find the prefix for me? So now we're trying to do the opposite. Now, do you know how many bits for the suffix here? So remember, we decide to give them 1,024. That's equal to 2 to the power 10. Can you tell me what's the suffix here? 10. No, the suffix is only 10. How much is the prefix? 32 minus 10 equal 22. So my prefix is 22. So if I want to write an IP address, what I have to do? Let's say now they decide to go start from this IP address. That's the first IP address. So what is my IP address? I have to write it. Can I write it like this, just like this? No, I cannot tell what is the prefix, what is the suffix. So what I have to do, I have to do /22. Perfect. So that's why the prefix length of a block is equal n minus log 2 of 1,024, which is equal to 22. Perfect. The beginning address is chosen. They decide to give the first IP address. That's the first IP address. Perfect. Now, how you want to write it? Simply, you write it. The first IP address /22, because we know the prefix is 22. What is the last IP address? You just add 1,000. In the top of that 1,000, and again it's a /22. So that's another type of question in the exam. So in the exam, I will tell you I have a company. They need 500 IP addresses. Okay, then I will tell you, can you give me the range? So the first step, what you will do, you will ask yourself, is the 500 is the 2 to the power a number? So the 500, what is the closest number for the 500? 12, correct. 5 to 12 is 2 to the power 9. So what is the suffix here? 9. What is the prefix? 32 minus 9, which is 23. Then what you will say, I will say the first IP address I want to assign this company is 10.10.10.0 /23. Always we put the prefix, not the suffix. /23. Okay, that's we know what is the first IP address? 10.10.10.0 /23. What is the last IP address? You add on the top of this IP address 212 and 512. So let's say you add it's gonna be 10.10.10.250. You have to do a math for that. It's not going to be that simple. It's not going to be, because the maximum number in the IP address is 255. Correct? So there's nothing called 512 at the end. So dot 255. But there is a way to find that. Don't worry about it now. We'll learn it later. 23. Don't forget, always the slash n is for the prefix, not for suffix. All right. That's one of the exam questions. All right. You know, don't worry about that. That's again, we know in the class A, B, C, there is no need to mention /8/16/24 because you know from the IP address. So that's just explanation. Don't worry about that. All right. Assume an organization has given a class A block 7273000. Can you tell me what is the prefix here? Is that I'm telling you that's class A, but how you're represented in the class list? Just you do /8. That's why you represent /8. All right. So what is the title here? Oh, submitting. All right, that's the same thing. In the class list, you can do submitting. So now if I have a range of IP addresses, let's say I have 1024 IP addresses. And I'm telling you, I want to divide that to 4 networks. So if you have 1024 IP addresses, you want to divide it to 4 subnetworks. How many IP addresses for each subnetwork? 265. Oh, I'm sorry, 256. Correct? So 256. How many? 256. Let me just write it here. Okay, I have, let's say, my network is 1024. This one equal to the power 10, correct? So what is n? 32 minus 10 equal 22. Perfect. Now I'm telling you I want to divide to my network to 4 networks. So how many each network I will have? Let's say I want to divide it to network A. I don't want to use A. Let's say network 1, 2, 3, and 4. How many IP addresses I will have here? Okay, this one is 2 to the power what? Correct, power 8. So can you tell me what is the, from here, can you tell me what is the n? 82 minus 8. So what is the prefix? 24. Perfect. So again, you can deal with the subnetwork is the same idea. You will see how many, when you divide it, how many IP addresses for each. And based on that, you will find what is how much the prefix, how much for the suffix. So the first step, the number of addresses in each subnetwork should be power of 2. Again, the same thing. When you divide your network, you cannot divide it like, if you have 1024, when you divide it to 2 networks, you cannot say, oh, 500 for the network 1 and the remaining for network 2. No, it has to be 2 to the power a number. So that's why it has to be 256 or 265 or 128 or 64. So it has to be 2 to the power 2, the same condition. But from there, what you have to do, you will find the prefix and the suffix for the subnetwork. And that's the equation. All right. Then the same thing, you will find the first IP address and you will find the last IP address. Same process, but I will show you now. Let's try to do exercise. Is there a question? All right. So here's an example. I have this organization had this IP address. What is the prefix to power? Is it 26, right? How many IP addresses I have here? Equal 2 to the power 32 minus 26 equal 8. 32 minus 26. 6 to the power 6. and that's equal 64. So how many you have in each? Are you sure? Yeah, so we have the whole range is 64 IP addresses. All right. So organization needs 4 subnetwork. So now you have 64 IP addresses. You want to divide it to 4 networks. How many IP addresses for each network? 64 divided by 4, right? Is 16. Perfect. So you have 4 networks. Each network will have 16 IP addresses. So now the question for you, what is the prefix and what is the suffix? Can you tell me? The 16, how will you present the 16? 16 equal to the power 4. That represent what? The suffix. So what is the prefix equal? 32 minus 4 equal 28. All right. So either you can do it this way or you just do this equation. You see this equation? N1, 2, 1 equal 2 equal N3 equal 4 equal N plus log 2 of, what is the bigger N here? Can you tell me? 64. Divide by how many per network? We decide 16. So that's the result, equal 24. So now, what is the prefix? Now, if you have an IP address, how you want to write it? So simply you will do, for example, 130.34.127/128. And that's how it's gonna look like. If you, do we have it here? So here. So initially, how many IP addresses we have? 64. What is N? Equal 26. What is the suffix? It will be 6. Perfect. Then you decide to divide it to 4 blocks. That's the first block, second block, third one, and fourth one. Each one will have only 16 address. Perfect. From here, you can, from the equation we did here, I'm sorry. From this equation, we find the 28. The 20, that's why we know it's 20, and it's equal to 28, 28, 28, 28. Then you find the first IP address, okay, and you find the last IP address. You can do that. How you find the last IP address? Any IP address or with not mask address. Perfect. So you can do that from there. So what's the time now, guys? Yeah, let's try to finish this chapter very quick. So now let's do more examples. So now mostly it's going to be examples. So the previous example, what we did, we divide the network to the same size of subnetwork. We say, you know, I have 64 IP addresses divided to 4 equal networks. That's why we say 16, 16, 16, 16. Now we have another organization, but they have a different requirement. So this organization, they have an IP address. The first IP address is this one. And is /n or /24. Can you tell me how many IP addresses you have there? How many total IP addresses I will have? Can you tell me? 2 to power 32 minus 24 equal 2 to power 8 equal 2, 5, 6. So I have total of 256, correct? So now let's see this company, they want to divide this 256 to a specific subnetwork. So the first network they want to do a sub block of 120 IP addresses. The second block, 60 IP addresses. The third block is 10 IP addresses. Now, what is the first condition? Has to be to the power 2. 2 to the power something. Perfect. So is that 120? Is this 120? Is this one 2 to power a number? No. So 120 is not going to be good. What is the closest number to 120? 128. So this one, I would say the first subnetwork, I want to give it 128 IP addresses. All right. 128 is 2 to power 7, correct? Now let's go to the 60. Is 60 is 2 to power number? No. What is the closest number to 60? 64. Okay, so I will give this range, I will give them 64 IP addresses. And this 2 to power 5. 6. All right, lower 6. We'll see now. We'll find the answer here. 2 multiply 2, 4. 4 by 2, 8. By 2, 16. By 2, yeah, 6. Perfect. Now let's go to the block 10. I need 10 IP addresses. Is the 10 to the power a number? No. What is the closest number? 16. So what I will do, I will give them 16 IP addresses, and that's and that's equal to 2 to power 4. Correct? Perfect. So again, the first step, I cannot just give them any number. I have to give them a block of 2 to the power number. I will find the closest number. We did the first step. So first of all, as we said, how many total IP addresses I will have? 256. The first address is 14.24.74.0/24. The last address is 14.24.74.255/4. That's when you have one block. That's initially. Now let's divide. Now we say when we divide it to 3. So the first subnet subblock, what we did is not a power of 2. So we allocated, we say we'll give them 128. And the subnet mask is 25. Why? Because how many we need for the suffix? 7. 7 plus 25 is 32. So that's why the mask is the first 25. Can you find the mask from this one? Can you find the mask if you have this IP address? What is the mask? Simply the first 25 bits will make it ones and the remaining 0. So you will find the mask. You don't have to worry about that. So if you do the math, if you remember, we know we can find the first IP address and then we can find the last IP address. Do you know how to find the first IP address? Can you tell me how we find the first IP address? You find the mask. That's the first step. Then if you want to find the first IP address, you AND it with the mask. And if you want to find the last IP address, what you will do? Not with the mask. Simple. So we explained that multiple times. So the trick here, what is the trick? I cannot give them on just 120. I have to give them 128. I cannot give them 120. I have to give them 128. Now let's go to the next block. What is the next block they are looking for? They're looking for 60. I don't know where's 60 gone. So 60 is not power of 2. So what I have to do, I will have to give them 64. I give them 4 extra. That's fine. All right. So from here, what is the subnet mask? The first 26 will be for the prefix, and the remaining is for the suffix. So, and how you find the mask? Simply the first 26 bits will make them ones, and the remaining will be 0. So you will find the mask. After you find the mask, can you find the first address? Yes, because we have to AND it with the mask. Can you find the last IP address? Yes, because we have to OR it with not mask. Simple. So what is the trick here? We did not give them just 60. We give them 64 because it has to power 2. Now, the last one, they ask for 10. Perfect. So how many we have to give them? 16. Then the same thing. The mask is 28 bits, so you will do the math. All right, so if we add all the addresses, remember how many we give them? 128, 64, and 16. How much total? It's going to be 208. How much initially do you have? Remember, initially we have 256 minus 208. So what does mean? You see here? That means there is 48 addresses is not in use. The last 48 is not part of any of these blocks. So how this gonna look like? If you look to the picture here, the first block we give them 128. Second block we give them 64. The last one we give them 16. There is 48 unused. All right. So from here, what you can tell in the class list, you can divide your block to a smaller block with different size. You don't have to just always give them class A, class B, class C. You can divide it and based on your need. If you need 1,000, I will give you 1,024. I'll give you more a little bit. If you need, 10,000 or 2,000, I will give you 2,000 plus something. It has to be to the power something. So I don't have to give the company a lot of IP addresses, and I don't have to give them few addresses. So I can manage that by using the class list. Clear? That's another example. It's the same thing. Let me go over the quick. So this company, this company has central office and has east office and west office. The central office is connected to the east and the west. So what does mean? You will have main office here or central office. It's connected to west office and to the east office. So east and west is not connected directly. We have to go through that. All right. The company guarantee a block of 64 addresses with beginning of address. That's the first IP address, and it's 64 bit. So the 64 is 2 to power 6. Perfect. That's why my prefix is 26. All right. The management has decided to allocate 32 for central office. So the central office will have 32 addresses and divided the rest between. So how many from the 64 and minus 32, how much left? 32. And you want to divide it between west and east. How much each? 16 and 16. So that's really simple. So if you look here, how many IP addresses for the central? 32. How many for east of 16? How many for the west? 16. Now, can you find the prefix? Correct? How you find that? How you find the prefix for the central office? 32 equal what? Power of 5. So what is your suffix? 5. What is the prefix? 27. So this one, that's why we have the prefix 27. Now, if you look to this one, it's 2 to power 4. What is your suffix? 4. Suffix 4. Prefix 28. That's why we have 28 here. Same thing here. 2 to power 4. What is your suffix? 4. Prefix 28. So can you find the mask from this one, from the 27? You have the first IP address, and you have this mask. Can you find the mask? I'm sorry. You have the n equal 27. Can you find the mask? Yes. So the first 27 equal ones, and the remaining 5 it will be zeros. Then you find the mask. Can you find the mask here? You can find it. Simple. Can you find it? It's gonna be ones. The first is 28. Then the remaining 4 will be 0. Same thing here. All right. So we did that multiple times. Then you do your design. I'm not gonna go over that, but I will show you the picture. So this picture, if you can tell, that is the main or the central office. It's connect to the east. Let's connect to the west, or the opposite, west and east. And you can find the first IP address for each one of them. You can find the last IP address. You can find the mask. So that's, you can go and review that. So that's another example. I will leave it for you guys. There's not much here to explain. It's the same thing, but different scenarios. Okay. There is something called the special IP addresses. Let's go over it. So there is a few IP addresses you cannot assign it to a device. Those reserved. The first IP address, which is called, what do they call it? It's called a broadcast, I think so. Let's see. It's using all zeros. Oh, example of using all zeros. So if the address is 0000, okay, contain only one signal address, reserved for communication when the host need to send IP address packet, but does not know their address. So, do you know anything about DHCP server? DHCP. DHCP. Dynamic host. IP configuration. Configuration. So now, let's say that you are in an internet and you just turn your computer on. Do you think your computer has an IP address? No, when you turn the computer on, your computer has no idea. So, can you decide what is your IP address? The answer no. So what you have to do, you have to ask a central server or service called DHCP. DHCP is the service responsible to assign IP addresses for each single computer. So when you turn the computer on, the first thing you will do, you will send a broadcast message. You will send a message. The destination address is 0000. Okay? What that means? Sending this message to everybody, saying, you know, what is my IP address? Asking everybody, do you know anybody? Anybody knows what is my IP address? Yeah. So this one is going to reach to everybody. So if you a computer, you will ignore it because it's not my job. I don't know what's your IP address. It's not my job to assign it. So it's going to go to all the devices, and then it's going to go to the first. It's going to go to the DHCP. So what the DHCP will do? It will reply back to you, you know, here's your ID. I will assign it. So now you have an ID. So that's why we're using this 000 is to broadcast to everybody looking for your ID. So that's why there's no computer has an IP address 000. It's reserved. Another example. So that's how it works. So there's a computer, new computer, we don't have an IP address. So what we'll do, we'll send a packet everywhere. What is the source? 000. And I send it to 255, 255, 255. Remember this destination 255, 255, 255. Remember we said that the broadcast. So I'm sending a message to everybody. Then it's at the end, it's gonna reach to the DHCP. What's DHCP will do? We'll send back a message. Here's your IP address. Use it now. All right. Second example is something called. We just explained that. It's called 255, 255, 255. That's the broadcast. So I'm sending my message to everybody. And that's why if you see, I'm trying to send a packet. Let me do it here. I'm trying to send a packet from this computer. Since the destination in the packet is say 255, 255, where this message will go. It's gonna go here, it's gonna go here, it's gonna go here, it's gonna go everywhere. The last one, this IP address, 127.0.0.0. This one, this IP address is used for troubleshooting. That's they call it loop back. So you're trying to test your computer, you're not going outside. So what's gonna happen, you send a message from your protocol, I'm sorry, from your application layer, goes to each layer, and go back again to the same layers all the way up. That's used for troubleshooting. You don't have to worry about it now, but that's the purpose. We use it a lot when we do a network troubleshooting. At least, if you want to say you have an internal issue with application, the first thing they use 172.0.0.0 to see if there is any error internally. So that's another IP address. Okay, so private. Let's cover a private address now. As you know, the IP address costs money. So if you want to buy an IP address from the provider, from the internet, okay. So if you want to buy IP address, the public, something called public IP address, that's going to cost you monthly. Because why they charge you? Because they will reserve this IP address only for you. Nobody else can use this IP address. So imagine if you have 1,000 computers. Imagine you have 1,000 computers. And you need an IP address for all these computers. That means you have to buy 1,000 IP address. That's going to be a lot. So what's happened here? They use a private IP address. So they will have a main IP address, a public IP address. It's facing outside. But internally, we will have a private IP address. We will be able to communicate internally with a private IP address. But when I go outside, we have to use this public IP address, right? And the same thing, if somebody trying to send something to you, has to go to this public IP address, then this public IP address will send it to the right computer internally. So that's why if you go to your computer now and type what is my IP address, it's going to give you now, just browse to the entry, go to Google Chrome, and just like what is my IP address, it's going to give you the public IP address assigned to the user. So that's IP address assigned only to you. However, if you go to your computer itself, you go to your IP address, you will see your IP address is 192.168.0.0, correct? So internally, I'm using something called the private. And usually it's something like start with this range, 10.0.0.8. That's if it's A. Most of the company, if you look to your computers, go to the to the command prompts, type. I can do it here for you guys. So here, for example, can you tell me what is my computer IP address? What's the command? ipconfig /all. Okay, what is my IP? Local IP address? Where's the IP address? Okay. So 216.87.12.228. So that's my IP address. That's the private IP address. What is the public IP address of the UB? So what you have to do? Go to Chrome. Okay. Just type what is my IP. What is this? 216.87.12.28. It's weird. Why are they doing that? Give me 1 second. Okay, where's the IP address? Yeah, they should not do like this. Again, that's I don't know why they do that, but that's wrong. But if we go here, what's the IP address here? Yeah, it's weird. I don't know why they're using the public. So they did something. But usually they're not using the private, they're using public, which is wrong. But anyway, again, did you understand what's the difference between private and public? So private, if you assign to your computer private, you can communicate internally. If you want to go outside, you have to go through the public IP address. If you want somebody coming inside, has to pass it through the public IP address, then it send it to a specific computer. All right, so I think this chapter it's covered. There is maybe more details you can cover it, simple details, that's a private. Discuss that. What this one? I'm sorry. Then, okay, don't worry about netting. That's something in advance. I'm not going to cover it today, but it's really something. Don't worry about netting. All right. So that's chapter 5. Is there any question? So summary of chapter 5. It's a very important chapter, and you will have a lot of questions like that. We talked in this chapter about the ID. Okay. First, we discussed the class of ID. The A, B, C, D, E. And we say how we can, from the ID address, you can tell what's A, B, C, D. Then we talk about the subnet, the supernet, and another topic and write it down. Then today we cover the cluster and why we use a cluster these days. So we eliminate all the issue with the cluster, all the issue with the cluster, right? Then we discuss how we find from two information, an IP address and the slash and location. I can tell what is the mask. I can know how many IP addresses in that range. I can find the first IP address. I can find the last IP. Same thing we learned about the subnet, subnet one. We have a range, we're divided to a smaller range. Then you can find the subnet mask, you will find the range of the IP addresses for each one. And you can find the first IP address. Is there any question? Good. Let's take a break. What's the time? Yeah, let's do another 30 minutes, but I want to take 5 minutes, please. That's fine. This time, that's fine. Submit. Next assignment. Don't worry about the first assignment. It's fine for everybody. So, guys, when do we have? Do we have a holiday coming soon? 25th? Is it a holiday? 25th? Who has that holiday? When you guys need the midterm? Okay, chapter 6. We are in network layer?
Yes, sir. Ready.
Okay, chapter 6. What we will cover in chapter 6? So we still in which layer we are still talking about? Network layer 3, network layer, right? Layer number 3, network layer. That's why we talk about the IP address, because IP address used in the network layer. So now we'll talk about more about the communication. Okay, that's why we say, how we deliver the packets. What is the name of the data we call it in the network layer? We call packets, right? So that's why now we will discuss the delivery of the packet in the network layer and the difference between direct and indirect. So we'll see that. Then we will go over the concept of forwarding. What's forwarding mean? All right. And this forwarding is going to be based on the address, destination address, or based on the label. What else we'll have? And we will discuss that in detail. So let's go. Okay. So a network, what is the network layer function? To deliver the packet from the host to the host, right? From A to B. So that's their job. It's not just the hub next to it. You have to make sure it's going through all these routers and reach out to the destination. So that's why we call it, and there's two types, direct and indirect. However, when we say forwarding, what do we mean by forwarding? Forwarding just we forward the packet to the hub next to it. Okay, so I'm just saying about how I deliver this packet to either router next to me or maybe a workstation. So that's called forwarding. We forward it from one hub to another one. However, the delivery it's from host to host. Doesn't matter how many hubs you have. You need it from the source to the destination. And the forwarding is based on the destination address, and the other one is based on the label, and we'll see what's the difference. So let's talk about direct and indirect. What is the direct? When we say it's a direct connection or direct delivery, when you are in the same network. So I'm sending something from computer A to computer B, but these two computers is in the same network. So that's why what we call about that. It's a direct connection. The second case, when you deliver the message from the last router to the destination. So for example, here, okay, let's say I'm trying to deliver something from A to B. That's a direct connection. I'm not doing it through a router. I'm just sending it directly to B. That's called direct connection. What's the second case? When you're trying to deliver something from the last router, so that data is coming from the internet, from here, from somewhere. It's coming, going to the router, then that's the last router. It's going from the router to the host field. So that's called direct connection. All right. So how many cases for direct connection? 2. Either direct from A to B or from the last router to that destination. Okay. So the sender can easily determine if the delivery is direct. How the sender knows that's the direct connection? If you find what you can do, find the network address for host A and the network address for host B. If the network address is the same, it's the same network, so you don't have to worry about it. All right. So that's you can tell it's a direct. It can be extract network address using what? Mask. That's why we need the mask. Mask is going to help you to find what is the network address. The IP address, okay, it's the same thing. So since it's a direct, what's the IP address will do? We will find the physical address. Again, when you build your message, physical layer need a physical address, not just IP address. So let's say now in network layer, you found the IP address. However, you have to translate the IP address to a physical address. And how do you find the physical address? Use algorithm for the algorithm. We'll explain that in chapter 8. So now I know what is the hub next to the address right away. I can tell what is the physical address through the AI. Let's do some example here. So now, what is the indirect? The indirect, the opposite. If it's going from hub to hub, from router to router, that's the indirect. Or it's from the source to the first router. So for example here, can you tell me, first of all, can you tell me from here to, okay, from here to here, it's direct or indirect? Before that, if I want to send something from, let's say, no, that's C. If I want to send something from A to C, that's direct or indirect? It's direct because it's in the same network, direct. Now, if I want to send something from A to this router, R1, it's direct or indirect? Indirect. Why? Because that's not the R1 is not the final destination. So that's indirect. So I'm sending something from R1 to R2. Direct or indirect? Indirect. For sure now. If I want to send something from R2 to host B, it's direct or indirect? It's direct because it's going from the last router to the destination. So if you look here, okay, from A to the first router, it's indirect. From router 1 to router 2, it's indirect. From last router, we say last router. So maybe there is 10 of them, but from the last router to the destination, it's called direct. What is the second case for the direct? If you want to send something from A to C, right? If you want to send something from A to C, that's another direct. So what that's mean? That's mean in any delivery, you will have at least one direct delivery, at least. And how many indirect? Zero or more. Can you tell me why 0 or more? If there is no router, I'm sending from A to C. Is there indirect? No, it's just direct right away. There is nothing between. So that's why it's 0 or more. Now, why it's more? Because maybe you have more than one router. So from router, that's why I say more. Why we say at least one direct? Because what is the smallest network you have? When you have two devices connected to each other. So that's why you would have at least. If there is no connection, that means there is no network. Yeah? So that's why we need at least one direct connection and 0 or more indirect. That's one of the exam questions. I cover that, so it's the same thing. So I'm not gonna go over that. So now let's talk about. So now we define what's the delivery, either direct or indirect. Now let's talk about forwarding. As we mentioned, when we say forwarding, you forward it to the device next to you. Maybe this device is another computer. So what we will have? Only direct delivery, right? But when you're forwarding, what you care about? You care about the physical address. So you have to find the IP address. From the IP address, you have to find the physical address, and you send it to the hub next to you. This device, maybe it's a computer, maybe it's a router, maybe it's a switch, maybe it's a hub. So it's a device, right? So how many type of forwarding? We have two. We have using the IP, the destination, or using the label. I will explain that. All right, so forwarding based on the destination and forwarding based on the label. Let's cover that. In this case, forwarding require a host or router to have a routing table. So how you will know I'm delivering a packet from A to B through a router? How you will know your path? So what you need a routing table. So this device has a routing table. It's gonna tell me I have to go this route. I have to go through router 1, or maybe I have to go through router 2. Then from router 2, I have to go to router 4. Then from router 4 to router, I don't know, then the destination. So you need a table. You need a table to tell me which way I have to go. So for example, if you want to go from here to New Jersey, and you type that in Google Drive. Google Drive? Google Drive? I don't know, I forgot. What's the word? Google Map. Google Map. If you want to go to New Jersey, when you Google Map, what's Google Map? It's going to tell you. I want to go to New Jersey. Who usually goes to New Jersey from you guys? Yeah. So the GPS, first of all, like I'm telling you from my house. I will leave my house. They'll tell me, okay, take right to Daniel's farm. Then after a few miles, take the exit, go to the route 8. So it's gonna tell you exactly. Then you jump to route 15. You know, from route 15, take exit 15B. You will be in route 287 or Cabanza Brae. Then from there, take exit 14A, Garden State. From there, take exit until I get to my mother-in-law house. So I'm going to my mother-in-law house until I get there. So the Google map, it's kind of the table or routing table. It's going to tell me from where I have to go, which route, which highway, until which destination, correct? So that's why we need a table. Okay, when the host has a packet to send, or when the router has something to receive, okay, or forward it to the next hop, you have to know the final destination. So when you build your packet, it has contained the source address and has to contain the final destination address. Why we need the final destination? Why I don't care about the one next to me? Because when I send it to the device next to me, the device is still, or the router has to open it, correct? And I have to see what is the destination, because I have to check my routing table. So the computer will check their own routing table. The router will check their own routing table to decide where I have to go. So that's why the source and destination address has to be always there. What is changing between hop to hop is the physical address. Physical address always changing from hop to hop. However, the source and destination always the same. All right. There is 2 different types of forwarding. We'll show you some example here. So the first one. Now, let's say I'm trying to send something from A to B. How the computer A will know I have to go through router 1, then I have to go through router 2 to find a destination. So I need table. So that's why we can use the host destination. So that is the routing table based on what? On the route. Okay, here. So computer A has this table, correct? This table is telling me if you want to go to host B, what I have to do. You have to go through R1, then R2, then you reach out to the host B. Now, R1, that's the table for R1. If you want to go to host B, what I have to do? I have to go to R2, then I will reach to the host. Now, R2, what's R2 will do if you want to go to host B? It's connected directly, then just as a direct connection, I will go to host B. Now, question for you. We have only 2 routers here. Imagine if you have 100,000 routers. What you have to do? You want to list that there, you want to say router 1, 2, 3,000, 2,000, 3,000. So it's going to be hard, really. So that's why nobody's using based on the route. I cannot list everything for you. I cannot list every street I have to visit. So in this case, what they did, they used the destination address. How would that look like? So if I want to go to host B from A, I want to go to host B, what I have to do? Just go to the R1. I have to go to the R1. Now R1, what will do the R1? R1 will open the packet, right? So I receive the packet from host A. In this packet, I will have the source address, which is A. I will have the destination, which is host B. So the router will open it. You'll see, oh, this one has to go to host B. Now, what's the router will do? I will look to my router one. We will look at the table. Oh, this packet has to go to host B. How I want to do that? Let me send it to R2. Just I send it to the one next to me. I don't care what's happening after that. I'm sending the router next to me or the right router, and this router has to handle that. So now router 2, what's going to happen to router 2? Tell me. We'll open it again. What we'll see, the source is A, the destination is B. I will go to the table, and I'm looking for a host B. That's the host B. What is the host? What is the next hub? There is no hub. It's going to the device. That device is connecting me directly. So now, what I did, what does your table look like? Only one entry for this device. You don't care what's next. You just host A. I know I have to go through router 1. That's what I have to know. I have to send it to router 1. Router 1, open it. Oh, this one has to go to router 2. Router 2, open the message or the packet. So, oh, that's the so that's what call it host. Now, question for you. Now imagine router 5 devices. How do do that? Now, send something to host. Something to host A from S. I'm sending something from S to host A. So you will have an entry. If you want to go to host, if you want to send something to host A, I have to go to router 1. If you want to go to B, I have to go to the router 1. C, I have to go to router 1. D, I have to go to router 1. So there is too many entries. All right. But in this case, what they say, okay, let's reduce that by using what they call it, the network host or the network specific method. So what that means, you know, that means any device in network 1, let's say you have S, you will have F, you will have G, you have devices. You want to send something to any device in network N2. So what I have to do? I have to go through R1. So how many entries you can do? Eliminating this 4 by. If my destination is N2, I will go through R1. So I will have only one entry for all these devices. Right? So I don't have to list all of them A, B, C, D. I can list the network itself. All right? The network address. Can you tell from the IP address what is the network address? Yes, using the mask, right? So that's the thing, you know, if you have device A, B, C, D, all of them, they have the same network address. So this N is the network address, N2 is the network address, N1 is the network address. So when you find the network address, you just send it to this router, and this router will know, oh, this network address, I have to go this route. So that's the third type, which is network specific. The last one, okay, the same thing. All right. So the same thing here. Let's say, you know, always any packet from network 1.
Bro, just paces
ante. Which route I have to go?
ఇద్దరు ముగ్గురేనా బ్రో చాలా మంది బాగుంటుంది
Router 3. I have to go through router 3.
మెరీనా హాల్
What about if I want to go from network 1 to network 2? I have R1. Now, sometimes you want to force your network to go.
మనోళ్ళే బాగుంటారు బ్రో
So anything is going from host A.
మనోళ్ళు ఇంకా అచ్చం తెల్లగా ఉంటారు అందుకని
to go not through another one of these specific has to go through why. Because sometimes you want to apply more security and restriction or stuff. So you're going to give host A to send the packet to any route. You want to tell them no, you have to go this way. So that's why you have to specify. You say host B, if you want to send anything to host B, which route you have to use. So that's why you do specific direction. So you can use the network specific, but sometimes you have to apply more restriction. A specific device has to go through a specific route. Question so far? Okay. Now, we
లైట్
have
బ్రో నిజం
something
చాలా
called
లైట్ బ్రో అది
default route.
మనకాడ ఏంటంటే అది అయిపోతే
What is
పూర్తి
the
మొత్తం
default
అయిపోయినట్టు
route?
అనుకుంటాం కానీ వాళ్ళు అలా
So
కాదు
let's say you don't have network
మన అది అయిపోయింది ఫైనల్ స్టేజ్ అనుకుంటాం ఆగురా
A, B, C.
స్టార్ట్
అయితే ఆగు వెళ్ళిపోతా
The rest of the internet. So you know I'm connected to network 1, 2, 3, 4.
ఇది మారిపోతున్నాడు అందుకని
But you cannot list every single router in the world, right? I'm connected directly to router 1, 2, 3. Perfect. But
అది కూడా ట్రాక్ నుండి
I don't know what's else. I don't know how many routers it's out in the internet. So what you can do, if I'm sending data from
ఏముంది
your
బ్రో
network to network 1, or 2, and 3, you can specify that. Then tell this packet anything else. If it's any packet is not going to N1 or N2, N3, then go to the default. I will show you an example. So we have another route, another it's called default route. So for example here,
ఓకే బ్రో
for example, if I want to send something from N1 to N2, I have to go through route 1. Correct?
మీ ఏటీవీలో ఉన్నప్పుడు అంటే బ్రో
If
ఒకే
you want
రోజు
to go to any type of other networks, what I have to do? I have to go through R2 is going to the internet. Internet has thousands, millions of routers.
అవునా
I will show you some example there.
లోపల నుంచి లోపలనే బయటికి రాకుండా చూసేయచ్చు ఒక
What's the time, guys?
అదే మంచిగా
నిజమేరా మనం బయటకు వస్తే
So how's the table
బయటికి రాకుండా లోపల
for host A?
కూర్చోవచ్చు
How's the table for host A? How many networks you have here?
అంతా అయితే
So I have to go
Minimum
through
volume
R1. So if you want to go from
Bro,
if
city
you wanna
post
go
mall
to
ఏమడుతున్నాయి?
N2, you have to use R1.
ఇంకా
Maybe there is more here, I know. But let's say now I have R2 and that's the internet. If you want to go to the internet, the rest of the internet, I have to use the default, which is
మనం బయటకు వస్తే కదా మళ్ళీ టికెట్ అడిగేది
R2.
జవాన్ ఒకటి
So
చూసిన
let's do some
జవాన్
examples.
చూసా
పోలీస్ షర్ట్ మిస్ పోలీస్ షర్ట్ రెండు చూసిన ఒక టికెట్ తీసుకో
All right. Now,
$14
how you will be able to find?
ట్యూస్డే
How you will be able to
Monday.
find? How you want to be able to find what is the route? So you have a table, correct?
లాస్ట్ స్టాప్ అదే
You're trying to find what is the
టికెట్
which
పోస్ట్
route I have to use,
రేపే
which route I have to go through. So you have to find a process. So now, if you have a class full, if you have a class full IP address, so what is the first step you have to do? Find the network address, correct? So I'm trying to send something from computer A to computer B. First, I have to find what is the network address of computer B. So what is the first step you have to do? So from here, from the packet, each packet will have a destination address. Perfect. So you will grab the destination address. Now, if we are using a class full, so how many class we have? A, B, C. Perfect. So you will extract network address. How you extract the network address? Extract IP address, the mask, correct? Always we use the mask to find the network address. But before you find the network address, what you need? You have to find the mask
బ్రో ఒకే ఒక నెట్ ఉంది బ్రో నెట్ లో ఆడుతున్నారు
in the class file. Remember, we have class A, B, C.
ఒకే ఒక నెట్
If you know this IP address is a class A, can you tell me what is the mask? What's the mask of a class A? 255.0.0.0. What is the mask for class B? 255.255.0.0. What is the mask for class C? 255.255.255.0. So from the mask, I will be able. So that's why first I have to find the class A, B, C. When you know which one, then you will be able to extract the network address. Then when you find the network address, so our table is divided to 3 small tables. Class A, you list all the class A network in one table, class B in one table, and class C in one table. Why? You want to save the time. You don't have to. If you have a big table, you go search for all of them. It's going to take longer. That's why they decide we can divide it to three tables, small tables. If the IP address is a class A, just I have to go search here. I don't have to worry about this too. If it's the IP address is a class B, then I will go check here. I don't care about this too. So it's gonna save time. You don't have to search the huge table. Perfect. So now, question for you: how you will know if it's a class A, B, C? But how you will know if it's class A, B, and C? So remember, class A. How you will know if that's a class A? But what? How you know this IP address is a class A? Remember, if the first bit is 0, it's class A. When you see the IP address, the first bit is 0, is class A. How you will know it's class B? It's going to be 1 0. Start with 1 0. We discussed that last week. How you will know it's a class C? If it's 1 1 0. How you will know if it's a class C? It's going to be 1 1 1, 3 1s. Okay, when it's a 3 1s, what you have to do? Can I use a class E or D? No, those we cannot use them for any device. So that's why if it's a class D or E, I will throw an error. So no, that's a wrong IP address. I cannot use this IP address. So how we will find what is the IP address? It's really simple. There is algorithm, there is multiple algorithm, but this one, how you will know if it's a class A, B, C, D, E? How many bits you have in the IP address? How many bits? 32. Correct? 32 bits for the IP address. How many bits we care to know if it is A, B, C, D? The first. Remember, the first 4, it's going to tell me if this IP address, if it's A, B, C, D, E. So what you have to do, the operation simply, how many the IP address is? Let's I have IP address 0, 1, 1, 1, then 0, 0, 0, 0, 32. Okay, total is 32 bits. So what we have to do, we'll have to do shift right, how many times? 28 times. What that's mean, you start shifting your bits. So you will see shifted first time, it's going to be 0, 0, 0, 0, 0, 0. Then it's going to be 0, 0, 1, 1, 1, and add another 0. Then when you shift this number 28 times, what is left for me? It's going to be left 0, 1, 1, 1. Then everything's. So now what is this number?
5 minutes vasta,
So
bro. 5 minutes vasta.
only the last 4. When I shift them, then I care about the last 4. Now, this number, I will translate it to decimal. If this number between 0 to 7, I will know it's a class A. If it's between 8 to 11, it's a class B. 12 to 13, it's class C. 14 is B, and 15 is C. So if you do this algorithm, that's algorithm that's applied here. You see here? This algorithm, it's applied here. It's coded here. So when you have an IP address, you insert it to define the class. It's gonna tell you if it's a class A, B, C, or D and E. So that's how this one functions. Using this method. Clear? So in the exam, if I give you an IP address and I tell you, can you please write the code how to find the IP address? So its simple answer is going to be, I have to shift the number 28 times, shift right 28 times, then I will check the number, the final number. If it's between 0 to 7, it's class A, from 8 to 11, class B, and okay, simple. Now, is enough today, guys?
Yes, sir.
Oh, okay. Yeah, because the chapter is still long, so I had a wish to finish today, but that's fine. All right. Again, next week, there is no class, correct? Okay, and the midterm will be the following week, Monday the 16th. So it's very important, very, very important to install in your laptop the lockdown problem. Without that, you will not be able to do the exam. You will get 0. I don't care. So it's your responsibility. Install the lockdown browser. The exam will be from home. Okay, so it's going to be from home. It's very important to know that the system is going to track you. So the system will, did anyone do the exam through a lockdown browser? You tried before? Yeah, you know the process. You know, you will start the exam. It's going to take a picture of you. It's going to ask you to show me ID. It's going to test the voice. It's going to test the camera. So you need a camera. You need a microphone. You need your ID with you. So before you start the exam, it's going to ask you test your microphone. It's going to ask you test the camera. It's going to ask you show me your ID. All right. When you pass all the stuff, then you will be able to start the exam. Exam is going to be multiple choice. I forgot how many questions. Maybe 75 questions. Okay, you will have 2 hours. I forgot the time. 90, yeah, 2 hours, 90 minutes. Multiple choice. It's going to be from chapter 1 to chapter 5. And the most important thing, the exam, it's a random exam. So it's not going to be the same question for every single one of you. We have 1,000 of the questions, and this exam is going to grab random question for you. All right. Not only that, when you start your exam, you cannot go back. So question 1, you have to solve it. You have to make sure that's the right answer before you go to the next exam question. If you move on, you cannot go back. So it's very important. Question by question, make sure it's correct, and move to the next one. All right, and that's very important. Question 1 for you is not going to be the same question 1 for you. So if you sitting next to each other and tell you what's answer to question 1, he will give you A. You know, you will get 0 because the answer is C. So it's going to be random questions. My advice for you, don't try to ask your friend. First of all, try to be separate. Go to your room, close the door, because there's not enough time. It's going to be sensitive time. Don't try to cheat. When you use the lockdown browser, you cannot go. You cannot go there. You cannot do that. Not only that, the camera is on. If you're doing any moves, it's going to record them. It's going to send me a flag. Then I go back and watch what you do. Okay, if you try to open your phone, I will know. You try to talk to someone next to you, I can't do it. So that's why the exam is really easy. It's only 5 chapters. It's really simple exam, multiple choice. Don't go crazy. That's why try not to cheat. Don't waste your time. That's my advice. Don't waste your time. Just focus, multiple choice, simple exam. All right? Don't sit with anybody. You know, try to be in separate. So it means specific timing what? It means specific timing any time for the day. Yes, so you would start at 6 o'clock. Yeah, so usually what I do, I start like maybe 10 minutes before. So I will open the exam maybe 5:45. So the first 15 minutes, you know, you can start doing your stuff. Camera, stuff. Anyway, when you start the exam, it's going to give you an idea. So if you want to start, you can start at 7. Remember that. You start at 7, you know, the exam is going to end by 8. So the thing you need 1 hour. So that's why you always start early. I want to give you 60 and 90 minutes, but there is an end time. So don't start late. That's what kind of last semester we mean. Some of the students, they start the exam at 7, and they send me, oh, the exam ending while I'm doing the exam. Well, yes, because the exam is between 6 and 8. You have 90 minutes to take it. You can take that to the final time, you cannot check it. No, then you can exact question when you go next. That's it, you cannot go back. So that's why answer, review, and There's nothing, you cannot go back. You cannot go back. Why? There's a lot of reasons, because, we're not here in front of me, so I have to rely on knowledge. Start saying everybody. You have to do something. You have to start at 6. By 10, it's gonna end. Even if you start 7 o'clock, you know that that's 2 hours. But if you start 7, you will have another hour. So that's why if you do 2 hours completely to start to finish, it's not 2 hours you start anytime. No, I will be enabled by 6 o'clock, and then I will be disabled by. Yeah, that's fine. I can solve everything. By the end, even if I make it between 5 and 8. Okay, well, the timer only gives you 60 minutes. So if we start 5, we'll end by 7. If the student starts 6, then end by 8. If you start at 7, it's going to end. So that's why I will enable 5:45 schedule to start. Then you won't have to always. Don't be there. Don't start the exam at 7. But it's very important you have a good internet connection, please. Last year I had a few students, they had an issue with their camera, with the internet, they cannot help if you have a bad internet, they cannot help you. Maybe a few months. No, you want to. I can't do that. No, it's not gonna be, no, it's gonna be, most it's gonna be 1 point for each question. It's gonna be 1 point. So most of the question is gonna be 1 point. 70, maybe 75 question or 60 something, 65. But some of the question has 2 points because it's really a hard question. Okay, but it's 1 or 2 points. That's it.